In this video, we are going to look into the best books and resources that are available to study general theory of relativity. We are also going to look into what are the best YouTube lectures which will make the learning of general relativity much easier, and those who are doing a self-study, they can easily go through it. When I'm talking about resources, I'm mentioning both online as well as offline. I'm going to show you each and every book, what is the table of content, how you should study, what is the sequence, and some of the best YouTube lecture videos which will make the understanding of general relativity much stronger, and it will build the foundation step by step. Finally, I'm also going to tell you how you can get those books, what are the links, and the other details. My name is Shaunak, and you're watching this video on Physics for Students. I welcome you to my channel. So before we look and start delving deep into the books and resources, let us look what are the topics that we are covering. So the topics we are covering is just a bird's eye view on general relativity, the best books on special relativity, what are the best books on tensors, what are the relativity topics which are covered in the books of tensors, what are the books of differential geometry, what are the books on general relativity, what are the best lectures of general relativity available on YouTube, what are the sequence of watching those videos, and where to get those books and resources. I mean to say, these are the topics that we are going to cover because these books and topics are related to each other. So we would be taking a step by step, and we will learn and we will see what are the books, the contents, and other details. Before we go ahead, just a very quick idea, although you know what is general relativity. So general relativity, also known as the theory of general theory of relativity and Einstein's theory of gravity, is the geometric theory of gravitation which was published by Albert Einstein in 1915, and it is the current description of gravitation in modern physics. So general relativity generalizes special relativity, and it also refines Newton's law of universal gravitation, providing a unified description of gravity as a geometric property of space and time, or four-dimensional space-time. In particular, the curvature or the four-dimensional space-time curvature is directly related to the energy momentum of whatever matter and radiation are present. The relation is specified by the Einstein's field equations, a system of second-order partial differential equations. Now here in this particular illustration, I have just shown you that it is the good old Newtonian laws of gravitation is further getting extended to space-time curvature, and space-time curvature means black hole and event horizon and white dwarf and neutron star. Geodesic, the straight lines are being replaced by geodesics. The time and space, which was during the classical deterministic world was time and space separately, is being unified to space and time, and the Einstein's field equations represents the entire tenet of relativity, and the stress energy momentum tensor actually shows the distribution of matter over space and time. It opens up our avenues for cosmological research, black holes, gravitational time dilation, as well as gravitational waves. So this is just in short what is general relativity. I think you already know, but it is a good time that we can just brush over the basic concepts. Okay, so before we go ahead and take a deep understanding on the books and how we are going to learn, the base of general relativity is based on special relativity, tensor calculus, and differential geometry. So before we go into the books of general relativity, the sequence, the content of the book, I would just like to give you a basic understanding of what are the best books of special relativity, what are the best books of tensor calculus, and how and what are the best books of differential geometry. Mind it, without these three things, without knowing special relativity, without having a complete grasp over tensor calculus and a basic understanding of differential geometry, it is impossible to learn general theory of relativity. So I would first like to show you what are the special relativity best books. Now here is a book which is written by Edwin Taylor and John Archibald Wheeler, We don't need to give an introduction for that. This is a book which is called Space-Time Physics. The second book which comes into our mind about special relativity would be the Feynman Lectures on Physics. It covers Feynman Lectures on Physics covers electrodynamics, classical mechanics, and things like that. But it has got a very intensive and a thorough understanding of special theory of relativity. I would also recommend Springer's Farooq Rahman's The Special Theory of Relativity, a Mathematical Approach. This is also a tremendous and a great book to look into. The Feynman Lectures on Physics is available online, so there is no point in purchasing the book if you're okay with looking into online stuff. So it is chapter by chapter. Even you will see Feynman's handwriting, the scripts, the lecture notes, the mathematical calculations, the illustrations, everything is given. I mean to say, what else do you need? This is one of the finest and the best lectures available in the world, and it is available at Caltech's website. Here I have given you the link, and I'm giving that link also in the description box, so which you can go. Now, this is a very popular book of relativity, international bestseller by Albert Einstein. You can go into it. I would also strongly recommend to go through Professor Leonard Susskind's lectures on special theory of relativity. This is astounding. This is, one of the best lectures that you can have. So just go to YouTube, type out special relativity lecture. I am also giving the link of special relativity in the description box so that it becomes easier for you to find. Okay, so if we look a little bit more into the space-time physics books, as I told you, that what exactly is, I just wanted to give you a basic idea that how easy it is to go through this book if you're a self-learner, if you've got no teacher and you're going all your way. So you see that you have to start first start with this book, and you see that here the entire calculations, I mean to say from Lorentz transformation, from the classical mechanics to Lorentz, and then to space-time physics, it is given in this way. Our relative speed relative to Earth frame equals to distance we cover. So I mean to say, before even going into signs like x, y, and variables like Greek tau and mu, this book covers and gives you a very clear idea, and it doesn't mention the variable, which sometimes become difficult for a freshman's physics to learn, and is given in a very elaborative way. Same into this, that space-time interval between two invariants, you see that it is given time separation squared minus space separation squared equals to interval squared. So I would say this book is extremely easy to read. It has got a very intuitive approach. The mathematics is pretty simple. It does not rely too heavy on the Greek symbols and further intricate details, and it is very simple to understand. So this would be the first recommendation of special relativity. The Farooq Rahman's book is equally good, as you see that it actually starts with special theory of relativity, giving the force, which implies the second order derivatives, and then it goes into mass energy relation and further into matrix. So this is, I mean to say, this is a pretty easy book for special relativity. You can just pick it up, just requires a basic calculus, trigonometry, and arithmetic, and you can learn and go through that book. Okay. So because in many occasions in my earlier videos also, I have shown that the foundation and the edifice of general theory of relativity is all about tensors. If you don't understand tensors, if you don't have an understanding of tensors, it is impossible to get a proper understanding of general relativity. So there are numerous available books of tensors in the market. Which one to pick up and which one to start with, that creates a confusion. So my first recommendation will be Daniel Fleisch, Vectors and Tensors. Now you might see that this book is basically a student's guide, so it would contain the basics of vectors and tensors. That is wrong. This book is so intense, this book is so detailed, that I will just show you that it contains the most important elements of general relativity in this book itself. So I would also recommend Principles of Tensor Calculus by Taha Sochi, and the third one would be Vector and Tensor Analysis by G.E. Hay. Now all these books are basically building up the basic blocks, that is tensors. I would also recommend to go for Borisenko and Tarapov's famous book Vector and Tensor Analysis with Applications. because until you understand the applications, it would be difficult for you to understand the implications of tensors. This is also another great book by Louis Bland, and most importantly, Tensor Calculus and Differential Geometry, one of the best books that I have ever gone through, by Prasun Kumar Nayak. So these are the more or less 6 books. I mean to say, these are overall one of the best available resources. You can just start picking up any one book with Daniel Fleisch and go into it. So because, as I told, that people might think that it is all about tensors and what is relativity at all, which is hidden in this. I would like to show you what are the relativity chapters that Daniel Fleisch is covering. So you see that it covers metric tensor, which is one of the 3 ingredients of general relativity. The entire causal structure is stored here. Then the entire this tensor derivative, Christoffel symbols, most importantly covariant differentiation, because once we go into curved space-time and even the components of the vectors are varying, we need covariant differentiation. And the Riemann curvature tensor, we can look into my playlist in general relativity. There has been 1 or 2 videos on Riemann curvature tensor. This is also being covered. It also covers a few important things of relativity, covariant and contravariant vector components, because in some way the covariant tensors operate, sometimes the contrast, so this is also being covered. So this is all in all what Daniel Fleisch, apart from base building, the basics of vectors and tensors, these are the topics which is covered in the book, which is related to general relativity. Now, Principles of Tensor Calculus by Taha Sochi, I would say this is one of the best books for a step-by-step learning. It is very detailed. It contains all the lesson plans right from the beginning. It contains a lot of illustrations, pictures, photographs. So it would be a very easy approach to learn tensor calculus on a step-by-step approach. You see, it starts with the preliminaries, then the nomenclatures, then it goes into space, coordinates, and then it starts with the tensors. So right from the very basic beginning, I mean to say, if I assume that you don't know anything about tensors, this book on a step-by-step would give you a right approach. So you see, first the spaces are being covered, and then from transformation and orthogonal transformation, he slowly moves into tensors. The second part would concern the different types of tensors, the isotropic, the symmetric, the covariant, contravariant, and most importantly, these books contain a lot of examples of tensor operations, addition, multiplication, subtraction, and the tensors operations using scalar. So this is one important thing, that although Daniel Fleisch books I have read, it contains a lot of tensor operations, but this book ideally contains much more examples. Coming to the next part, as you can see, it also covers these topics like contraction, inner product, and then it goes into identity development, metric tensor, most importantly, the dot product of using tensors, the cross product, the scalar triple product, and the determinant of the matrix using length and area. So you can see that it takes absolutely kind of a baby step in order to make you understand and develop on those areas. It also covers Laplacian tensors in application, most importantly tensors in mathematics, and here you can see I've marked box in red. It shows tensors in geometry, which include Bianchi identities, Ricci curvature tensor, and Ricci Riemann Christoffel curvature tensor. These are the integral part of general theory of relativity, and Taha Sochi's book covers that. Okay, this is the next important book of tensor calculus and differential geometry by Prasun Kumar Nayak, and as you can see that it also covers the most important part of general relativity, Riemannian metric. Then it starts with affine connections, goes deep into partial derivative, curvilinear coordinates, Christoffel symbols, and covariant differentiation. It further covers Christoffel symbols in much more details and covariant differentiation. Then it moves into divergence, Laplacian operator, curl, intrinsic derivative, and finally into Riemannian geometry. So pick up this book. This is an absolute great book. I personally have this book and I have read it. It contains almost the entire gamut of tensor calculus as well as differential geometry. Finally, I would like to show you that it also covers relativistic mechanics, even space, Minkowski space. So you can say that it covers a lot of physics also. starting from mass energy relation, Minkowski four-vector, generalized relativity. So overall, it is not only a pure mathematics book, but it covers a lot of physics stuffs also into it. Okay, next we come to G.E. Hayes' book on vector and tensor analysis. Very simple. It starts, I have just skipped with the initial part. It covers tensor analysis, contravariant, covariant, and here you can see properties of tensor. Then it goes deep into Cartesian tensors. This is one of the best books. I can tell you, I mean, all of them are best, but this is one of the best books which undoubtedly you can check it out. Now, this book of Borisenko and Tarapov, Vector and Tensor Analysis, it contains a lot of illustrations. I mean to say, when we are reading tensors, especially in space-time manifold, it sometimes becomes very difficult to visualize those things in order to do the pure mathematics. So these are some of the, the tensor concept, the cylindrical coordinates, and you see beautifully both Borisenko and Tarapov have used them. So the illustration part, no doubt, is one of the best in this book. I mean to say, the earlier books doesn't contain really that amount of illustrations, photographs, graphs, etc., the movement of the curves, the ellipsoid, the stress tensors, etc. But this is one of the best books I have seen, which contains a lot of illustrations, and it makes easier for us to visualize. Okay. So now what we do is that we come to differential geometry, which is again one of the integral part of understanding general relativity. And I have to say that you need to understand this. I have got separate lectures on differential geometry. I'm planning to more on that. Let us see what are the best books. Okay. Now, first of all, I would like to tell you Tristan Needham's Visual Differential Geometry and Forms. This book actually has created a kind of a, I would say, it has created a stall. I was talking to a few of my friends over Facebook and to my few of my professors. They are telling that this is the book of the century. So Tristan Needham is actually a British mathematician. It is always better to know a little bit about the author. And he is a professor of mathematics at the University of San Francisco. And during the time when he is doing his PhD, his academic advisor was none other than the famous Nobel laureate, Dr. Roger Penrose. Okay, so now let us look into what are the things that is there. First of all, I would like to show you, these are some of the reviews which I have collected from Amazon. Excellent, looks like another classic, great book with real example, not just theoretical exercises, visual differential and sister book, visual complex analysis. So I mean to say, the reviews actually, tells a lot. So all these reviews from Amazon and others, I to be very honest, I never read those reviews before making this particular video. I just went through this book and I found it's one of the greatest classic that Needham has ever produced. Although there is another book called Visual Complex Analysis, which deals with the complex analysis part, but this is just tremendous. Okay, so it starts with the nature of space. I can tell you this book contains a huge amount of illustrations. So if you're getting a photocopy of that book, be sure that the colors and the illustrations are proper. Otherwise, it carries no meaning because it is written visual differential geometry. So it carries a lot of visual things. So it starts with the Euclidean and non-Euclidean geometry, Gaussian curvature, etc. Then it moves into mapping surfaces, the metric, which is most important, the conformal maps, the Beltram is insight. Then it further goes into parallel transport, which is the key of covariant differentiation in general theory of relativity. Then it further goes into what is called an intuitive geometry proof. So you see the Gauss's theorema egregium is being covered, the Gauss-Bonnet theorem is being covered, and then we move into neighboring geodesics. So it covers everything. Apart from that, here you see that it covers the Riemann curvature tensor. Very, very important in a very lucid and simple manner. The Riemann, the parallel transport of around a small parallelogram. Then it goes explaining components of Riemann tensor. Then sectional curvatures, which is very important. In one of my videos, I have covered sectional curvature. And then it covers the most important part, the Ricci tensor, which I have highlighted, the acceleration of the area enclosed by bundle of geodesics. Then it comes to the Riemann's curvature tensor, which is integral part of general relativity. And finally, it comes to Einstein's curved spacetime. You can see the happiest thought of my life, the equivalence principle. It covers the spacetime metric, the Schwarzschild solution, and the Einstein field equation with matter. And finally, it comes to gravitational collapse to a black hole. So, and then you see that the cosmological constant, which Einstein called as one of the greatest blunder of his life, is also being covered. So, visual differential geometry and forms by Tristan Needham is an absolute must. For those who are starting with differential geometry, I used to say we'd start with Andrew Presley, but this book coming into my hand, I would say that let us start with Needham. Yeah. So, the next book which I will always consider classically would be Andrew Presley's Elementary Differential Geometry. Then you can pick up Thomas Bankoff's Differential Geometry of Curves and Surfaces. This book by P.M. Wilson is equally good, Curved Surfaces and An Introduction to Differential Geometry. These are the four books. I will show you what are the table of contents covered in this. First, starting with the very fundamental Andrew Presley's book, and it's an undergraduate mathematical series. So you understand that it will be very easy. I'm going to say quite clear. So it starts with the surfaces, then moves into first fundamental form, curvature, Gaussian, geodesics, and so on. I have not covered the entire, but it is a very simple book. I think that anybody can just pick it up and just start reading on sitting on a couch or a sofa, and you can understand the basics of differential geometry. Andrew Presley, remember, one of the best books of differential geometry. Okay, coming next to this is Thomas Bankoff, Stephen Lovett. I would like to show you who these people are. Actually, Thomas Francis Bankoff was born on 7th of April 1938. Is an American mathematician specializing in geometry. He is a professor at Brown University, where he taught since 1967. He is known for his research in differential geometry in 3 and 4 dimensions, for his efforts to develop methods of computer graphics in the early 1990s. Coming with that is Stephen Lovett. He has joined the Wheaton College in 2008. He received his PhD from Northeastern University, and his specific research and teaching interests include abstract algebra, algebraic geometry, differential geometry, and cryptography. As a result of his positive experience as an undergraduate student at Brown University, he is working on differential geometry ebooks. Okay, so differential geometry on curved surfaces is a very good book. I have just laid down the basics. So it starts again with plane curves and moves into global properties, then curves in local properties, curves in global properties, and so on. So I just wanted to show you that this is again a very simple book. I just forgot to mention, remember Andrew Presley's book and this Thomas Bankoff and Stephen Lovett books. Do not assume that you know topology. I mean to say, there are a lot of differential geometry books who will assume that you know topology, but this is not. So you can very well start with this book. Okay, so this gentleman, Thomas James Wilmore, is actually an English geometer. Why I'm telling it will soon become clear to you, and is best known for his work on Riemannian three-space and harmonic spaces. And here you can see the Wilmore surface, which is actually from his Wilmore conjecture. There's a sculpture which is there at Durham University in memory of Professor Thomas James Wilmore, one of the greatest thinkers of our time on Riemannian surface and other areas, complex areas of differential geometry. This book is just an absolute Bible, an introduction to differential geometry. So you can start this book reading as usual with that. So it will start with the tangent and go into metric, local, intrinsic properties. It will also cover the second and the first fundamental form, the minimal surfaces, and here you can see it covers differential geometry of surfaces in the large. So Hilbert's lemma, complete surfaces, Hilbert's theorem, all of these are being covered. It further covers areas like tensor calculus, which is very important, and Riemannian geometry, which covers the metric, geodesics, and geodesic curvature. So this is, I would say, a very serious and a kind of a very important book. In order to learn different general theory of relativity, we need to go through these topics. So covariant differentiation, Riemannian geometry, the metric, the curvature tensors, the geodesics, parallel vectors, everything which is required for general theory of relativity is we are building upon basics. Okay, now we finally arrive in what are the general relativity best books. Remember that we are covering the best books part, and then we will see into what are also the YouTube videos. Okay, what are the best books of general relativity? First, to start with, Student's Guide of General Relativity by Norman Gray. This book is wonderful, by Robert M. Wald. Then the classics, Sean M. Carroll's Space-Time and Geometry. The General Theory of Relativity by Farooq Rahman. And most importantly, one of the best books of general relativity is Taha Sochi's General Theory of Relativity, Simplify and Assessed. This is one book. Apart from that, I would also suggest Relativistic Tool by Eric Poisson, The Gravity, which is one of the classic books by James B. Hartley. This is a first course in general relativity. This is more or less related to gravitation, but more into cosmology by Steven Weinberg. And one of my favorite and the best, Gravitation by Thanu Padmanabhan. Now, these are, I mean to say, if you can go back to this, these are the 1, 2, 3, 4, 5 books. Among them, I would recommend you to start with Norman Gray and then move into Robert M. Wald, not to touch with Sean Carroll and Farooq Rahman. Then you can go into these books and you can start immediately with Thanu Padmanabhan. Remember, out of these 1, 2, 3, 4, 5 books which is there on the screen, these 2 books are a little bit heavy and a difficult read. I use the word difficult not in literary sense to mean difficult, but compared to the other books which I have been showing, these 2 are a little bit heavy. So you can just skip on to these books to read it when you grow mature in terms of the brain. Now this book by Taha Sochi, General Relativity, Simplify and Assess, it really doesn't have a very good review. I mean, not much people have read through it. So this is just a screenshot of Amazon. Now, what are the topics that they're covering? It first covers the mathematical background that is required. You see the cover is very interesting. It shows, I think, on the top, this is the Schwarzschild metric. Then it shows the classical. Then it shows the 4 pi g rho, that is the gravitational potential. Then it shows the geodesic equation, and finally the compressed version of Einstein's field equation. If I'm not wrong, you can put it in the comment box. So it starts with the mathematical background, and then it further moves into formalism of general relativity, the solutions of the field equation, classic limit of general relativity, frames, coordinates, and space-time, and what are the different tests of general relativity. So all in all, it's around a 400-page book, but it covers almost everything with nice demonstrations and a lot of illustrations. I don't need to tell much about this book. This is an all-time great book, Space-Time and Geometry by Sean M. Carroll. It starts with special relativity in space-time, then it moves into manifold, then it covers gravitation, Schwarzschild solution, black holes, perturbation theory, cosmology, and QFT in curved space-time. Just a point to note that this book by Sean M. Carroll is more into mathematics, less into intuition. So if you are looking, I mean to say, there is never an intuitive understanding of general relativity, but in case if you're looking to have a rather, I would say, a light, easier approach, this is not the book. I would repeat, this is quite intensive and quite mathematical in nature. This book is an absolute gem. It is Robert M. Wald's General Relativity, and you see how it starts. It starts with manifolds of tensor fields, then it moves into curvature. Once it has covered the curvature, it covers the Einstein equation, the homogeneous isotropic, and cosmology. I've just given overall the book content because it is too long. Schwarzschild solution is given, methods for solving Einstein's field equation, this causal structure, and finally it moves into cosmology like singularities and asymptotic flatness of black holes. It further covers areas like QF, quantum effects and strong fields, and what are the appendices, etc. So all in all, it is, I would say, it is more or less a medium category in terms of the complexities are concerned. Very good book, quite detailed and easy to understand. Okay, now this is my favorite. It has always been my favorite. Even I keep it always on my table while doing my study. James Hartley's book on gravity is much more of an illustrative, and it contains lot of in-depth analysis of gravity. Remember, it was James B. Hartley and Stephen Hawking who developed this no boundary theorem in the later part of his life. So these are few of the highlights of this book. It starts with geometry as physics, moves into the Newtonian part, then the special relativity, then the curved space-time, gravity, and geodesics, and so on. So I mean to say, all the books, if you look into the, in general, the approach of the book, the table of contents they are covering, more or less all of them are the same. They do not go any weird or bizarre way, but each of them are unique because they carry their own typicalities in terms of explaining further things. So these are a few of the points. So it covers a lot into cosmology, which covers the spherical structure of a star, the gravitational collapse, astrophysical black holes, the universe observed, cosmological models, and then finally the Einstein equation. So it is a kind of a heavy, around 450 pages of book, a flat one, easy to read, easy to understand. And here are some of the features which I would like to tell. It is a very well designed book. It is easy to understand, not much of complexities are given. It is very illustrative. I mean to say there are a lot of real life photographs of testing the twin paradox, gravitational waves, black holes, etc. So it will be easy and quite visual for you to understand. Lot of relativistic tests which are being performed, which we really do not know is being covered. It contains a lot of detailed explanations, and most importantly, which is known for this book, is the applications of relativity in terms of the real life, whether it is a gravitational probe or anything like that. It is being done in this book. So 1, 2, 3, 4, 5, 6, these are the important points of this particular book of Gravity by James Hartley. Most importantly, the applications, the illustrations, and the design and the structure and the pedagogy and the methodology of this book is very unique. It is a must for those who are learning general relativity. These are few of the, I would say, reviews of from Amazon. All of them shows very good self-study, generally a good textbook, and explanations in detail, but confusing in some parts, just to show you what are the basic reviews from Amazon. Okay, so we call this as the Big Black Book, and this is one of the best books, although some people do refer to as a reference book, but for me, it is the best book for step-by-step learning. It is heavy, very heavy to hold on to hand, around more than 1,000 pages if I'm not wrong. So it starts with geometry dynamics in brief. It covers flat space in space-time. Then it covers the electromagnetic fields, electromagnetism in differential form, stress energy tensor. So this is the stress energy tensor in this Mr. Thops and Villiers book is covered in huge details. Then you see it covers the differential topology. Now here is a problem. This book will contain certain amount of details of topology. So you should be clear on that. If you're not, then it's better not to look into this right now. The geodesic, the Newtonian gravity in language of space-time, and the Riemannian geometry, metric and foundation of all is being covered. Then we move into the equivalence principle, how mass energy generates curvature, the weak gravitational fields, and then it moves into conservation of laws of angular momentum. So here is the mass energy generates curvature, I mean to say the integral part of general relativity is being covered. Then it moves into cosmology. So the relativistic and spherical stars, the pulsars, the quasars, the supermassive stars, and then the stellar positions, the Eulerian versus Lagrangian perturbations, which is very important for satellite positioning. All these are being covered. As I was telling, it's a very heavy book, contains huge amount of details, right? Then it moves into gravitational collapse, the Schwarzschild geometry, everything. I mean to say everything, all in all, anything you want to know about general theory of relativity is covered in this book. Black holes, while black hole, the equations of motion, it goes into gravitational waves, generation of gravitational waves, geodesic deviation, and detection of gravitational waves. Okay, so we are done mostly with the offline part, that is reading through book, and here comes the most interesting, the YouTube videos of general theory of relativity. Now, just before I start this section of the video, I just want to tell to all of you that there are millions, maybe more than that, YouTube lectures on general theory of relativity. I have picked up which I found to be the most pertinent, the best one, and which will have a kind of an easy understanding of general relativity. First, hats off to this person, with due respect, one of the greatest teacher of all times, Professor Leonard Susskind lectures on general theory of relativity. But before you start watching those lectures, just hear me out, because there are certain things which I would like to point. Now, general theory of relativity, this is the lecture without any question, one of the greatest lectures ever found on the surface of Earth, Professor Leonard Susskind. So this lecture, this is one you will get on September 2008 at Stanford University. These carry a little bit of, I would say, not so clear in terms of the visual. The audio is excellent. It's a little bit old, as you understand, 15 years or 14 years from now. So these are a few. This is the first lecture of general relativity, and you know it contains a complete playlist, and you can find it out in YouTube, and I'm giving it in my description box also. So the next one which comes is this one. As you can see automatically that there is a difference in terms of resolution and the picture and the color. The same kind of lecture, and this is on September 2012, 4 years later, almost 10 years from now. So I just wanted to tell you, I may be wrong telling this, but what I found is that there is a difference in terms of the complexities of 2008 and 2012 lectures. 2008 lectures are more or less, I would say, kind of a clear lecture, which is taking us step by step. But somehow I found the 2012, right from general relativity lecture 1, the professor has taken much more into intricate details. Okay, what I was just willing to tell you that this is an important note. The note is that you will learn, if you consider Professor Susskind's lectures, taking his lectures and going one by one. So you will learn more on Newtonian mechanics in depth. Remember that general theory of relativity being a classical theory, the Professor Susskind teaches a huge amount of details of Newtonian mechanics, because without knowing that, we won't be able to know more about general relativity. Second is that this is the best form of relativity. Third is that you will see, I think most of you will agree with me, that there will be new interpretations which the professor moves along while giving the main subject of the lecture. New analysis emerges, new results also come out, which sometimes becomes confusing to a beginner. I remember the first, second, or maybe the third lecture where I was talking about the Gauss's law and how he integrated Gauss's law with the law of gravitation, and he found out a new way in sphere, etc. So remember that when you are watching Professor Leonard Susskind's lectures, it is obvious that because of its depth and analysis, he will interpret new things which seems to be moving out or deviating from the main subject, but it is not. And that is why it makes up a great teacher. If you have watched my video on how to become a good mathematics teacher, I made it a point that give the students something which Google cannot give or which internet cannot give. This is one of the best examples. So as Professor Susskind gives a totally new aspect, you might find something that it is far away from the subject. Most important is that you need not to know anything earlier. There are no assumptions, and the professor teaches everything except basic arithmetic, calculus, and trigonometry. So this is just a note before you go into Professor Leonard Susskind's lectures. These are the 5 points. I think if you keep it in mind and watch it, it will be better. The next online learning is MIT's OpenCourseWare. Here is it directly from the website of MIT. So these are great lectures, and you will see that these lectures are given. The playlist carries all the names. So it starts with the geometric viewpoint, then it goes into tensors, then the tensors are continued, then volumes and volume elements are being introduced. It is just great. So this is the 2020, very recent, 2 years back lectures of MIT OpenCourseWare. You can very well select it. Every single details is being covered. Quite easy. I would say, yeah, rigorously mathematical, but an excellent way to learn. Okay, you might be wondering who is this person on the screen. Now, this is Eduardo Martin Martinez. He is a professor of mathematical physics at University of Waterloo and also associated with the Perimeter Institute, and his research areas are basically quantum information, general relativity, quantum field theory, and quantum gravity. He also has great lectures. So here is just an overview of who he is in terms of at the university. So on the right hand side you see Perimeters Institute, where he is associated, and I think that he recently got an award also, the Polai Award, back in 2014 or 15. So this is his YouTube channel, and he mentions, hello, I'm Eduardo Martin, and I'm professor of mathematics and associated at the quantum computing at Perimeter Institute, and this is the details. Okay. So these are the lectures of general relativity, quite mathematical, quite rigorous, but it is generally a pleasure to watch. So this is about Martin. Okay. Another important Indian mathematician, I would say general relativist, Thanu Padmanabhan, recently passed away in 2021, I think 17th December if I'm not wrong. He was an Indian theoretical physicist and cosmologist whose research actually spanned a wide variety of topics in gravitational structure, formation in the universe, and quantum gravity. He published nearly about plus 300 papers and reviews in international journals. He made several contributions related to analysis and modeling of dark energy in the universe and the interpretation of gravity as an emergent phenomenon. Now, Thanu Padmanabhan's lectures are a pleasure to watch. This is a few of the lectures I have given. Also, this link in my description box, you can find it out. There is just one point you have to understand, that these lectures, the topics somehow are not mentioned in the playlist. So it is just general relativity lecture 1, 2, 3, 4, 5 on, and you can just click on that and understand. But these are very sequential lectures, excellent, deep in mathematics, great understanding. So you can go through lectures of Thanu Padmanabhan. This is the IUCAA Pune's website. I would say the channel, which you can go and understand. Okay. Neil Jeffrey Turok, I would say, I don't know whether I'm pronouncing it right or not. He is a South African physicist. He holds the Higgs Chair of Theoretical Physics at the University of Edinburgh in 2020, and he has been a Director Emeritus at the Perimeter Institute of Theoretical Physics, and he specializes in mathematical physics and early universe physics, including the cosmological constant and a cyclic model for the universe. Now, I would say that this Professor Neil Turok's lectures are amazing. I mean to say, this is the first time that I found that these lectures are starting from the inception. Inception means it starts with special relativity, and even prior to that, Maxwell's equations. So this is Professor Turok, teaching on the board, and these are the lectures, as you can see. Now, you can find these lectures, although there is not a specific, I would say, kind of a channel in YouTube, but this is the one, Neil Turok. You can see a little bit details at PRIRSA, that is Perimeter Institute Record Seminar Archive. I will just show you that this is one of the best. I have never seen a lecture so detailed, which starts initially, you see, with Maxwell's equation, and because Maxwell's equations are the pioneer or stepping stone of special relativity, which united in 4 dimensions. It starts with there and goes into Lorentz transformation. Then here you can see coupling gravity Riemann tensor, then the Einstein tensor, and then finally with the linearized gravity. So you can find these details here, https://pirsa.org/Neil Turok. Now there are people who have created YouTube channels of their own, where they are plugging in Turok's lectures also, but this is the authentic website of Perimeter Institute, and there are other classical mechanics and other lectures also. I can tell you, this is one of the best lectures of general relativity, which starts from scratch. So what would be the sequence of watching these YouTube videos? I would say, let us start with Neil Turok, then move to Professor T. Padmanabhan, then to Professor Leonard Susskind, and then to Eduardo Martin. The reason is that Neil Turok deals more with Maxwell's equation, then special relativity, then general relativity. So it is one of the best. It just starts with the scratch with Maxwell, then moving into SR and GR. Then comes Professor T. Padmanabhan. It starts also with special relativity. It's mathematical, easy to understand. Then the great Professor Leonard Susskind, who deals only with general relativity, black holes and cosmology, and has got a very deep understanding. And Eduardo Martin's, it is a little bit advanced in nature. That is why I kept at the fourth point. So all in all, these are the YouTube videos, the sequence and how you should watch. The summary I would like to tell is that we learned about a little bit of general relativity. I would recommend to go sequentially, get a very good understanding of special relativity, learn about the tensors, learn about the basics of differential geometry, go through the books, and then watch the videos in the sequence that I have mentioned. So this video completes here, and it gives you a thorough resource of understanding of books and online stuffs, YouTube videos, links, everything. Now, if you really want to know or you want to have this book, obviously it's a soft copy, please do email me at editor@physicsforstudents.com. You can find my email ID given in the about box of this channel. And if you're connected with me in Facebook or otherwise, you can ping me in Messenger or you can WhatsApp me. I would be glad to send those soft copies to you. Yeah, obviously, I would request all of you now to subscribe, like, and click on the bell icon to get all the notification from Physics and Students. Please do put up your comment, and I will try to put all the links over there in the description box. Feel free to connect with me, email me, WhatsApp me, and you can get get connected with me, and I will try to mail you whatever the books that I have got. I will be coming up next with a few more interesting videos to general theory of relativity. Stay tuned and don't forget to click on the subscribe and put up your comments. This is Shaunak signing off from Physics for Students today, promising you to come back yet with another very interesting video. Till then, goodbye and have a nice day ahead. Bye.
Now, you can be a part of our team. You can send your scientific articles, essays, research papers, lesson plans on a particular subject of science. For further details, please write to us at editor@physicsforstudents.com. Stay safe and happy.